Hello, I'm Tim Erbes, the Director of Engineering for Orolia Defense and Security, and today I have a really cool demo for you showing you off the BroadSim Wavefront product, as well as a really cool unit under test. So, BroadSim Wavefront is a software-defined SERPA simulation system. That means you can use BroadSim Wavefront to test anti-jam antennas, multi-element antenna systems, things like that. Today we've actually connected the BroadSim Wavefront directly to our unit under test, which is the Northstar, which is a product by Yoo-Hoo Technologies. And on the right-hand side of my screen, I have the Yoo-Hoo Northstar web UI open here so we can see what the unit under test is doing as it tracks the signals being generated by the BroadSim Wavefront. The Yoo-Hoo Northstar is kind of an advanced interferometry type system. It's actually finding angle of arrival of the GPS signals in the CA code domain. So the simulation's already running. You can see on the left-hand side, I have a map showing the simulation point as well as the threats that are orbiting around me. The CA code signals are being generated and presented to the multi-RF ports of the unit under test in a phase coherent manner. We achieve 1 degree of phase coherency. We actually do that through a real-time feedback calibration process. And you can see over time we measure the phase offset between the multiple elements, and then we can compensate those offsets as we continue running the simulation. This guarantees that the simulation remains phase aligned for the entire duration of the test. So on the right-hand side, the Northstar is showing a handful of blue dots. Those are the locations of the GPS satellites based on the downlink data or the broadcast ephemeris. So that's where the satellite should be. And the green dots represent where it appears the signal's arriving from according to the Northstar's interferometry. Now you'll notice that some of these green dots are almost exactly on top of the blue. Some of them are a little bit further away. This is typical with this device. We see the same behavior when we connect it to live sky antennas. It just has to do with the fact that CA code is a very low power signal, and the power levels of the different satellites are fluctuating. There's a lot of satellites in the sky. So this is about what we would expect for a clean sunny day scenario. But really, the Northstar is designed to be a situational awareness, specifically looking for GPS threats. And so we're going to show some threats today. We're going to show how the Northstar reacts. And you're going to see how we can use the BroadSim Wavefront to generate those threats. So it's kind of a really cool demo. We're really showing off both products here and how one helps us test the other. So the first thing I'm going to do on the left side, I'm going to go into my Wavefront simulation here and turn on my spoofer. So my spoofers and jammer are flying around me, but currently their signals are turned off. So we're going to turn on the first spoofer here. So just go into settings, go down to my spoofers, go to spoofer 1, and enable the signals. And then I'm going to go back to the map screen here. Now, spoofer 1 is actually a pretty weak transmitter. It's only 7 dB stronger than a nominal GPS signal. And so we're going to watch what happens over time as these signals are presented to the multi-element system. Okay, so right away we see the green lines are connecting the blue dots of where the GPS satellites should be versus where they appear to be being received from. So the Yoo-Hoo Northstar is saying, GPS satellite 14 should be over here, but it looks like it's coming from the horizon. And then it flags that as a spoofing event because it can tell that several satellites all seem to be arriving from the same location. And you can see that the compass view on the Northstar agrees with the map here on the left-hand side that spoofer 1 is basically directly south of us, and it's flagging this as a spoofing event. Now, another interesting thing here is you can see there's some satellites now that are showing up below the horizon. So GPS 16 is being received from this location, from the spoofer, but GPS 16 is not even supposed to be in the sky right now. And the Yoo-Hoo Northstar figures it out, and shows you that it's below the horizon, but yet it can still receive that signal. Now, the reason this is the case on my simulation side is because the constellation on my true signals is different than the constellation on my spoof signals. And that has some satellites are in common, so some of them are in agreement in the sky, but some of them are not. And this is because the spoofer is not obligated to do everything the same way as the true signals. And it's important that devices are able to determine that's what's going on. And it's important that we have the complete flexibility with BroadSim Wavefront to allow you to create those kind of spoofing tests. We completely allow the spoofer to be independent. It can be for a different time, different constellation, different code types. There's a lot of flexibility there. All right, so now I'm gonna go turn on the second spoofer. And then I'm gonna go back to the map screen. Now the second spoofer is stronger than the first one. So it's about 25 dB above reference level. So right away, spoofer number 2 actually shows up as a jammer according to the Northstar. That's because it received a significant amount of power from that location. You also see that it was quicker to notice the spoofing signals because of that stronger power level. It was easier to detect. And all of the satellites now seem to be arriving from this location. And you actually see that there aren't any green dots underneath the blue anymore. And that's because this spoofer is strong enough that it's actually hard to see the true signals at this point. It's sort of a combination of a spoofer and a jammer at the same time here. And as that spoofer orbits us, you can see the Northstar updates the location. So we really love this demo because it helps us show that the angle of arrival of the multi-element wavefront simulation is in fact working. You cannot achieve this kind of accuracy on angle of arrival unless you have a really good wavefront system. And at the same time, it's really cool because we're testing the Northstar's capabilities, which would be really hard to do without a simulator because it's not easy to go out into the field and do these kind of spoofing tests. All right, so next I'm going to turn on the jammer. So this jammer is about 45 dB higher than GPS reference signals. And you can see that it did pop up on the Northstar screen for a minute, but right now we have a lot of signal involved. We have 2 spoofers and a jammer. So I'm going to give it a minute to settle things out here. Okay, so now the Northstar is detecting 2 jammers. One is our jammer 1 and one is our spoofer 2. And you can see that the green dots appear to be coming from the spoofer 2 location. And that's showing that these signals are arriving from the horizon, not from where the satellites should be. So that's clearly a spoofing event. I hope you enjoyed this little demo. I think it's really cool. I'm going to keep playing around with this. If you have any other questions, check out our contact information underneath the video, and don't be afraid to reach out to us. Thank you.